Welcome back to episode 25. We're going to be talking about the logical and bitwise operators. So let's start with the logical. First one is the two ampersand symbols. This just stands for the word and then the second one is two vertical lines. You can find this button above the enter key on the keyboard. This just stands for the word or. So let's say we have two Boolean values here, a and b, true and false respectively. Let's evaluate these expressions. So a and b means that a has to be true and b has to be true, and that's false because b is false. And then the second expression here is A or B, so only one of them has to be true for this to be true. And A is true, so that turns out to be true. Moving on to the bitwise operators, they're called bitwise because they operate on the binary directly. And so you can see here we have two byte variables, and one is set to this and the other set to that. Anyways, our first two is the or again, and then the and these do the same thing really that these did, just they work directly with the binary, and we differentiate between the actual logical operator and the bitwise just by using one of them instead of two. So let's look at these. So for the or, we look at the bits one by one, and if one of them is 1, then we write a 1. So there you go, we get down here to where there's two zeros and we write a 0 because none of them are 1. Anyway, for the and, we just look and see if both of them are 1s, and if so, we write a 1. So that's what that's doing. We have this symbol here. I don't know what this is called, but it's top left of the keyboard, and it's just called the complement. So we complement the byte A, and we just basically flip the numbers. So if this is 0, we turn it into 1. If this is 1, we turn it into 0, all the way down. And then this exponent here stands for XOR, and this just stands for exclusive OR. So if we look at the bytes, only one of them can be true, not both of them. Where when we had the OR, we could have two of the bits being 1, and that would still work. But with the XOR, only one of them can be true at a time. So if we look here, 0 and 1, that'd be 1, 1 and 1, they're both 1. So this would be 0 because only one can be 1, and all the way down the line. So anyway, the next ones I did a little research on because like I've never seen these before, but anyway, I'm sure they're used somewhere. Anyway, this is called a sign shift left. So we take the binary and just shift it one place to the left. So you can see here 0 1 1 0, and you can see I just shifted it 1 1 0, and so on and so forth. And I shifted it 1 bit because I specified that here. We could say 2, 3, however many we want. And then we have a signed right shift. So this is just going the other way. We're taking that that byte or however many bits you have and shifting it down, however many you specify. And then we have this where it has like triple angular brackets, and this is called a unsigned shift right. And the only difference between the unsigned shift right and the signed shift right is in the signed shift right, if we had a 1 out here, and this was like our sign bit denoting like a negative number, then that would be retained and it would just be pushed back into this number. But with the unsigned shift, if there was a 1 here and we shifted that away, it would just be gone. It wouldn't matter if this was a negative number, it would just be gone. So just as a disclaimer, like I said, I haven't really worked with these directly before, so if you know that I explained something wrong, then just let us know in the comments. So anyway, those are the logical and bitwise operators. Now we can go ahead and move on to loops.